Hello friends, welcome to this session of maths. Today we are going to look at polygons. So what exactly are polygons? Polygons are closed shaped figures formed by line segments. So in the earlier session we learned about triangles. So triangle is a polygon. Similarly, squares, rectangles, pentagons. Squares and rectangles are shapes of four sides, a square and rectangle, and pentagons are shapes of five sides. So that way all these shapes, these are closed shapes. What do we mean by closed shape? It means that if you start from one point and you draw the entire figure, you will return to the same point, right? And also it's a closed shape, and you will also see that any 2 points on these closed shapes, any 2 points that you take, the line segment forming any 2 points lies completely inside the closed shape. For example, if you consider a shape like this is not a polygon. It has 4 sides, it is closed, but it's not a polygon, because if you select these two lines, or rather these 2 points, and you draw a line segment, this portion of the line is outside the closed shape. So this is not considered a polygon. A polygon is a closed shape figure in which all the points joining any 2 particular points lie inside that closed shape. When all the sides are equal, the polygons are called regular polygons. For example, in triangles we saw all the 3 sides of a triangle, if they are equal, the triangle is called equilateral triangle. Similarly, for a quadrilateral, that is a shape with 4 sides, if all the sides are same, you get a square. Similarly, pentagon with all sides same is called regular pentagon, regular hexagon, regular heptagon, octagon, nonagon, and decagon. So this is individually, this is 3, 4, 5, 6, 7, 8, 9 and 10 sides respectively. This is an interesting property, sum of internal angles of a polygon. So let's say the basic thing that we are using here is that the sum of internal angles of a triangle are 180 degrees, that we have studied in the last session, right? So we are using the same property. Let's say we have a polygon with n sides, right? What we do is we select the first point, we draw, we connect it to A3. So A1 we connect it to A3. A1 and A2 are already connected because it's the side of the polygon. So we connect it, we do an internal construction, we do this. Similarly, we do this, and we continue, right? So out of those n points, we are able to draw from a particular point, we are able to draw n-2 lines. Why n-2 lines? Because the 2 points immediately next to that point from which we are drawing all the lines, they are already connected. So we will not be able to make internal lines from there. So we have n-2 lines, and you will see that because now we have split this entire polygon. If you look at these lines are splitting the polygon into triangles, right? So this is one triangle, this is one triangle, this is another triangle. So that means we have n-2 triangles. So it is going to be n-2 triangles into sum of all internal angles of an individual triangle is 180. So n-2 into 180 is going to be sum of all internal angles of this particular polygon of n-sided polygon, right? Sum of internal angles of n-sided polygon is n-2 into 180. You don't have to remember this. If you just remember this logic that we are going to split it into n-2 triangles, it is n-2 into each triangle is contributing 180 degrees. So sum of all internal angles is going to be n-2 into 180. So let's look at this table. This table again, you don't have to remember, it is fairly logical. So if you're talking about a shape with sides 3. That shape is called triangles. The sum of internal angles of a triangle is 180 degree. And in case it's a regular polygon, as in if all the three sides of, or rather all sides are equal, then what would be the angle? So in that case the angle is going to be 60 degrees. Every angle is going to be 60 degrees. 180 divided by 3. Quadrilateral is a closed shape with 4 sides. So if you apply this formula, n is equal to 4, so n minus 2 is 2. 2 into 180 is 360. You will see that any quadrilateral is basically made up of 180 degrees. Two triangles of 180 degree each, so it is 360 degrees. So 360 divided by 4 is going to be 90 degrees. For a regular polygon, which is basically a square, each angle is 90 degrees. Similarly, for a regular pentagon, each angle is 108. The sum of all internal angles of pentagon is 540. So similarly with hexagon and heptagon also. So we can continue this table as such, but the idea here is for you to familiarize with this concept of n minus 2 into 180 degrees. So now let's look at quadrilaterals. Quadrilaterals, as we already know, four-sided polygons. This diagram tries to give you a classification of quadrilaterals. So quadrilateral is of two types. One is a kite, the other one is trapezium. The kite is a quadrilateral in which two adjacent sides are of equal length. They may not be parallel to each other. For example, this line is not parallel to this line because that is not required in a kite. So basically think of it as a kite. So this is how we draw a kite, right? So these adjacent sides are equal, these adjacent sides are equal. So that is the only criteria for a quadrilateral to be a kite. The second type of quadrilateral is trapezium. It's also called trapezoid in the US. So trapezium is a quadrilateral where two lines are parallel and the others are not, or may not be. By definition it is not required to be. So only two lines are parallel, the other ones are just connecting any two separate points on these two lines. So trapezoid is again if these non-parallel lines are also parallel. If these non-parallel, these lines are parallel anyway. If the other two lines are also parallel, you get parallelogram. If the other two lines are not parallel, we get a regular trapezoid. In the regular trapezoid also, if the sides are equal in length, then you get isosceles trapezoid. If the sides are equal in length and are also parallel, then we get a parallelogram. Parallelogram again of two type. If the adjacent sides are also equal, that means all four sides are equal, you get rhombus. If the angles are 90 degrees, you get a rectangle. If rhombus and rectangle, if both criteria are satisfied, that means adjacent sides are also equal and the angles are also 90 degrees, so you get a square. So square is the perfect type of a quadrilateral which has all these properties. Also rhombus, because all the sides are same, it also means that adjacent sides are same, so it also happens to be a kite. Basic concepts again: quadrilateral, perimeters and area. Perimeter, as you know, sum of lengths of all sides. Area is going to be for parallelogram, for a figure like this, where this line is parallel to this and this line is parallel to this and also equal in length. This is going to be base into height, so this is base and this is height. So we are not talking about this length here, okay, not slanted length. We are talking about the height of the perpendicular, so that is base into height. Length of rectangle, length into height. Area of rectangle, length into height. Same thing, base, which is basically the same as base into height. Area of a square, again length into height, but length and height are same, so it becomes side square. Area of a trapezoid. Now this is interesting. Let's look at this trapezoid. So let's say this height at the base is A, and this height at this length at the base is A, and this length at the base is or at the top is B, right? And let the height be H. So what we do is we will consider this rectangle. We'll cut it into a rectangle, the area of which is easy to find out, right? And we'll join this triangle with this triangle. So what we get is two separate closed figures now. One is a rectangle. What is going to be the base of the rectangle? The length of the rectangle is going to be b and height is going to be h. So it becomes b and h, right? Now look at this. From this triangle is basically, we are only talking about this much length in the triangle, right? Only this much length. So what is that length? So that length is actually a minus b. So you have this whole length, out of which we are cutting this b length. So we get a minus b. So the base of this triangle is a minus b and the height is h. So if you apply the area, so area of these two is going to be half b a minus b into h. This is the area of the triangle, plus area of the rectangle is going to be b into h, right? So area of a trapezium is going to be equal to the area of triangle plus area of rectangle. So what do we get here? So we get a by 2 minus b by 2, sorry, ah by 2 minus bh by 2 plus bh, correct? So minus bh by 2 plus bh, we get ah by 2 plus bh by 2, correct? So this quantity is half of this, so 1 minus half is half. So again what we get is half a plus b into h. So this becomes the formula, which is again given here. Base 1 plus base 2, that is a plus b into height into h divided by 2. So this is the formula for area of a trapezoid. Quadrilateral solids, these are three-dimensional figures in which the base is a quadrilateral. So any cube kind of a solid figure will be a quadrilateral solid. Now here a cube is a figure the base of which is square, whereas any rectangular solid is a base of which is a rectangular polygon. For example, it could be rectangular hexoid, in which case we'll have an hexagon at the bottom, and then we'll have a three-dimensional figure right there. Okay. Surface area of these three-dimensional solids are sum of all the areas of all the faces, right? So we are if we are talking about a cube, we are talking about this area, plus we are talking about this area, then we are talking about top area, then there will be a corresponding bottom area, then left side area, right side area, back side area. So there are 6 surfaces here, bottom, top, and the 4 on the sides, and we are talking about the sum of areas of all these. So basically as much surface of the cube that is exposed, that is called surface area. Volume would be base into height. Base would be this will be area of the base into height, right? So this is again going to be length into width into height in most cases. Properties of quadrilaterals. Parallelogram, we have already seen parallelograms, as the name suggests, corresponding sides or opposite sides are parallel. So we are talking about a figure which has opposite sides parallel. I'm sorry, this doesn't look parallel. So we're talking about a figure that has opposite sides parallel like this, and also opposite sides are equal. If opposite sides are parallel, the opposite sides are also going to be equal, right? And then because the opposite sides are equal, the opposite angles are also going to be equal, right? So these are the properties of parallelograms. Opposite sides are equal, opposite sides are parallel, opposite sides are equal, opposite angles are equal, adjacent angles are supplementary. What do we mean by supplementary angles? So adjacent angles, as in we are talking about A and B. So A plus B is equal to 180 degrees. So that means that is the definition of supplementary. So what we mean here is that 1 plus B is equal to 180 degrees. Diagonals of parallelograms bisect each other. What do you mean by bisect each other? That means they will cut each other in half. That means this length is going to be equal to this length, and this length is going to be equal to this length. They may not be parallel. They may not be perpendicular. Sorry. If they happen to be perpendicular, then there is some special property that we'll consider later. If they are perpendicular, they will this parallelogram will become a square. Okay, they need not be perpendicular, but they will bisect each other. So these are the 5-6 parameters on which we'll look at the properties of all the quadrilaterals. So one would be whether the opposite sides are parallel or not. The other one will be whether the opposite sides are equal or not. Their opposite angles, whether they are equal or not. Adjacent angles, and the diagonals, whether they bisect or are perpendicular that way. So these are the 5-6 properties through which we will look at the other type of quadrilaterals also. So let's move on to rectangle. So again, you know, rectangle is a special type of parallelogram. So all that we just saw on the last slide will definitely hold true, right? So this is going to be equal to this. Opposite sides are equal. The only additional thing we are going to have is that all angles are 90 degrees. So all angles are 90 degree means the adjacent angles are supplementary. 90 plus 90 is 180. Opposite angles are equal. That is also true because all angles are 90 degree. So basically all this reduces down to only 3 properties. Opposite sides are parallel and equal. All angles are 90 degree, and diagonals bisect each other. So we're talking about this diagonal, and we're talking about this diagonal. So they bisect each other. So all the properties of square, because square is a special type of rectangle, so all the properties will remain the same except one additional property, that the diagonals are going to meet, not only going to bisect, but they are also going to meet in 90 degrees. So all opposite sides are equal, parallel, all opposite sides are equal. All angles are 90 degree, all sides are equal. The diagonals of square bisect each other and are also perpendicular to each other. So rhombus, we have seen that it's a special type of a kite, and what makes it a rhombus is that all sides are of equal length. So the properties of rhombus are opposite sides are parallel and equal in length, all sides are equal, diagonals bisect each other and are also perpendicular. Let's move on to trapezoid. Opposite sides are parallel. We have already seen in the classification slide. So there are 2 types of trapezoids. One is a regular trapezoid. Usually this is how you find a trapezoid. The second special characteristic of this trapezoid would be when these non-parallel lines are sides are equal. So non-parallel sides are equal in isosceles trapezoid. Both angles coming from parallel sides are equal. So as in this angle in isosceles trapezoid is going to be equal to this angle. Otherwise it will not be. Like for example here, this length and this length is not the same. So this angle and this angle will not be the same. Just another way to represent the classification, we have a Venn diagram here. The Venn diagram, the universal set is quadrilateral. All quadrilaterals will fall in this rectangle, big rectangle that we have. There are some trapezoids, they are completely separate. All parallelograms will fall in this red circle, out of which all rectangles will fall in blue circle, all rhombuses will fall in this gray circle, and intersection of rectangle and rhombuses is going to be square. So maximum and minimum area with respect to a given perimeter, there are certain rules that you need to remember. Any regular polygon will provide the maximum area for a given perimeter and the minimum perimeter for a given area. Now this looks very complicated. Let's look at it closely. Any regular polygon. So wherever we are talking about polygons, so we can know the easiest case would be to consider a triangle, right? So let's say a triangle, any regular polygon, that means it has to be an equilateral triangle. So this is equilateral triangle will provide the maximum area for a given perimeter. Okay, so let's say if I say a perimeter is 30 centimeter, it has to be. So that means all the sides when added should give me only 30 centimeters, not more than that. Then if you have multiple triangles, different triangles, sides of which will give us a perimeter of 30 centimeters, out of all those, the maximum area will be that of the equilateral triangle of side 10 10 10 each. And this property holds true for all regular polygons. So if we are talking about a particular length or a particular perimeter, then the maximum area will be given only by the polygon which has all sides equal. That means it has the regular polygon. This is one rule that you have to remember. The other way around, minimum perimeter for a given area. So if I say I want an area of 100 centimeters square, and if I have multiple triangles that give me areas of 100 centimeters square, right, the minimum perimeter will be of the equilateral triangle. So if you want to remember this, how will you remember this? So just remember this: maximum area for a given perimeter, minimum perimeter for a given area. Max A, min P. Just try to remember this: maximum area for a given perimeter, minimum perimeter for a given area. So let's just extend this idea further. Of all quadrilaterals with a given perimeter, square has the maximum area. Again, it is the same way, it is derived from this law itself. Of all the quadrilaterals of a given perimeter. So what do we have here? Maximum area for a given perimeter is given by a regular polygon. So regular quadrilateral would be called square is a regular quadrilateral, right? So square will be the quadrilateral that will give you the maximum area for a given perimeter. Similarly, of all quadrilaterals with a given area, square has the minimum perimeter. So for any particular given area, the quadrilateral that will give you minimum perimeter will be a regular quadrilateral, and regular quadrilateral is a square. So square has these two specific properties. The same way that we saw a couple of minutes ago, equilateral triangle, because it's a regular polygon, it tends to give maximum area and minimum perimeter. That way, similarly, square, because it's a regular polygon, it will give you maximum area for any given perimeter and minimum perimeter for any given area. So let's look at this problem. You can give it a shot. The perimeter of a rectangular field is 60 feet and its width is 12 feet. We know both the perimeter and the width. So let's say this is the rectangle. This is L, the length is L, and the width is say W. So perimeter is going to be 2L plus 2W, right? So it's 2L plus W. This perimeter is given as 60 and the width is given as 12. Correct? So let's put 12 here. So we get L plus W is equal to 30. That means L plus 12 is equal to 30. So L is going to be 18. L is going to be 18 feet. What is the area of this field? Area is going to be length into width. It's going to be 18 into 12. So it is going to be 216 square feet. Fairly straightforward. Let's look at this problem now. Give it a shot. A rectangular room. This is a room. A rectangular room whose area is 96 square feet has a side that is 2 feet shorter than 3 times the length of the other side. Okay. So let's say one side is X. So the opposite side is also become X. The second side is the adjacent side is 2 feet shorter than 3 times the length of the other side. 2 feet shorter than 3 times the length of the other. So that means this is going to be 3x minus 2. 2 feet shorter then 3 times the length. Correct? And what else do we know about the rectangle? We know that the area is 96, right? So what is the area? The area is 3x minus 2 into x is equal to 96. Correct? Okay, so let's just all we have to do is solve this. So we get 3x square minus 2x minus 96 equal to 0. So this is basically a quadratic equation that we have to solve. So we need to find out two numbers such that whose product is minus 96 into 3 is equal to minus 288 and sum is equal to minus 2. So let's factorize 288 first. So what we'll get is 288 is equal to 2 into 144, which is 4 into 72, which is 8 into 36, which is 16 into 18. Correct? So now 16 into 18 and the difference of that is also 2. So these two numbers can be of help. So if we choose if you choose 16 and minus 18, the sum of these numbers will become minus 2 and the product will become 288. Right? So we'll choose these two numbers. So what we get here is we get 3x square plus 16x minus 18x minus 96 equal to 0. What do we have common in these two? So we have x common. We have 3x plus 16. Here also we have 6 common. So what do we get is 3x plus 16 is equal to 0. So that means either x is equal to minus 16 by 3 or x is equal to 6. X cannot be negative because it's a length, right? So we rule out this possibility. So we consider x is equal to 6. So if x is equal to 6, this sides are going to be, this is going to be 6 and this is going to be 3 into 6 minus 2. That means 18 minus 2 is going to be 16. Correct? So what is the perimeter of the room? The perimeter is going to be 2 times 6 plus 16, which is going to be 22 times into 2 is going to be 44. So the perimeter is going to be 44 feet. Give it a shot on your own. The sides of a rectangle are in the ratio 3:7 and 60 times the perimeter of the rectangle is 20 times its area. Okay, so let's say this is a rectangle. The sides are in ratio 3:7. So let's say this is 3x, this is 7x, right? So this is 3x, this is 7x. Okay. 63 times the perimeter of the rectangle. So what is the perimeter of the rectangle? So perimeter is going to be 20x, right? So this is 7 plus 3 10th into 2 20x. 63 times the perimeter. So 63 times the perimeter, which is 63 into 20x. 63 into 20x is 20 times its area, is equal to 20 times its area. Correct? So that means let's 20 get cancelled. So what you get is area is equal to 63x. Okay. How much longer than the smaller side is the longer side? Because if you get area is equal to 63x, and let's independently find out what the area would be. So area is going to be 7x into 3x, right? Base into height. So 7x into 3x is going to be 21x square. So let's equate these two now. This and this will equate. So we'll get 21x square is equal to 63x. So x and x get cancelled. So x becomes 3. 63 by 21 is 3. So if x is equal to 3, what are going to be the sides? So sides are going to be 3x, which is 9, and the other side is 7x, which is 21. So how much longer than the smaller side is the longer side? So longer side is going to be 21 minus 9, 20 centimeters longer than the shorter side. Try to solve this. Okay, two cubes of edge 3 centimeter are glued together to make a rectangular solid. Okay, so now this is 3-dimensional. This we are dealing with cubes. So let's say this is one cube, two cubes of edge 3 centimeter. Okay, so this is the edge of this is 3 centimeter. Okay, so we are joining two such cubes together. So that means now we have this cube like this. So this common surface that was common to both has been stick. So that is no more, that does not exist anymore. So that means we are basically left with a solid, something similar in shape like this, and there used to be a cut here which is joined now. Okay, so we are talking about a shape like this. Two cubes of 3 centimeter are glued together to make a rectangular solid. What is the surface area of the new solid? Okay, so what is going to be the surface area? So this is going to be 3 centimeters tall, this is going to be 6 centimeters wide, and this is again going to be 3 centimeters deep, right? So surface area is going to be how many of such faces we have that have area 3 into 6. We have two such faces, one here and one on the back, correct? How many of these areas we have? We have 3 into 3, two such areas, one on the left and one on the right. So two areas of 3 into 3, and top and bottom areas. What are going to be the dimensions of top and bottom areas? Top and bottom areas are again 3 into 6, correct? So if you add them up, what we get is 4 times 3 into 6, which is 18, plus 2 times 2 into 3 is 9. So 4 times 18 plus 18, which is basically 5 times 18, which is 90. So 90 centimeters square is the answer. Practice problem 5. See if you can solve this. A cube of side 9 centimeters is split into 27 equally sized cubes. What is the combined surface area of new cubes? Now one thing that you have to remember is slicing and dicing of cubes. So there is a particular logic that you need to understand. Let's say this is a cube, right? So if I want to cut it into 27 equally sized cubes, or rather let's say if I want to cut it into 8 equally sized cubes, what will I have to do? I'll have to exactly cut it in the middle in all 3 dimensions. In the middle here, in the middle here, and in the middle here. If I do that, what I get is 1, 2, 3, 4, 4 cubes, smaller cubes on top, and 4 smaller cubes on the bottom. So we get 8 cubes. Similarly, if I divide, let's say this is a cube, I'm just drawing it bigger so that you understand it better. So I have this, let's say this cube I have. If I want to cut it into 27 equally sized cube, the only way I can do it is by cutting every face in 3 equal parts. So this is one type of a cut. This is the other 2 cuts, right? And the third type of cuts will be like this. So basically, if you have seen a Rubik's cube, that is the structure we are talking about. So we will take a cube, we'll cut it in such a way that individual pieces are 1/27th of the size, and we have 27 such pieces, right? So now we'll see what is the combined surface area of the new cubes. Okay, so we'll first of all let's see what is the size of this cube. This is 9 centimeters long. That means this is going to be 3. This is going to be 3, 3. So the individual cubes are going to be of size 3 into 3 into 3, right? Correct. So what would be the surface area of a cube of size 3 into 3 into 3? It is going to be 6 times the surface area of one particular face. All the faces have the same surface area, right? So it is 6 times 3 into 3. This is for one cube. how many of them we have? We have 27 of them. So we get 27 into 6 into 3 into 3. The answer is 1458 centimeter square. Let's move to the sixth problem. You can pause the video and see if you can solve this. Okay. In the cube below, what is the perimeter of triangle A-C? Okay, we'll first have to locate the triangle A' and C. Okay, so we're basically talking about this particular triangle. Okay. What is the perimeter? So we'll have to get individual lengths of these sides. Each edge of the cube is n centimeter long. Okay, so let's say this is n centimeter. So A' is equal to n, that we already get. What is going to be the length of AC? AC is basically the diagonal of a square, right? Because A, B, C, D is a square. This is a cube, so ABCD is going to be a square. So what is n? This is going to be AB is going to be n, BC is going to be n. So what is going to be the length of AC? AC is going to be root n. Oh, sorry, AC is going to be root 2n. Correct? Now let's look at this particular triangle. I am drawing it separately, A dash and C. So we know that A dash is n, AC is root 2n, and this angle again is going to be 90 degree, right? Because this is the angle that this line A dash is making with the base, that is going to be 90 degrees. So using Pythagoras theorem, what do we get? So A dash C is equal to under root of n square, this square, plus this square. This square is going to be what? 2n square. So we get that A dash C is equal to root 3n, right? So what is the perimeter of A dash A and C? A dash C, the perimeter is going to be n plus root 2n plus root 3n. Correct? What is the perimeter of triangle A dash C? So that means we say n 1 plus root 2 plus root 3. Now, so let's look at this problem. Pause the video and see if you can solve this. A hexagonal ground is split into 6 sections, each of which is an equilateral triangle. Okay, so we have, let's say this is one equilateral triangle. We join 6 such equilateral triangles to make a hexagonal shape. So this is how an hexagonal shape is going to look like, and you will see that because all these lines are of equal length, this is going to be a regular hexagon, right? So hexagonal ground is split into 6 sections, each of which is an equilateral triangle. If the perimeter of each triangle is 2 centimeter, so let's say the side of each triangle is x, so the perimeter becomes 3x, which is given as 2. Okay, so 3x is equal to 3. What is the area of the hexagon? Oh, great. So we are asked the area of this hexagon. Now you will see that area of the hexagon is going to be 6 times the area of every triangle, right? Because it's made up of 6 equal triangles. So let's find out basically the area of every triangle. Let's say this is the triangle and every length is 2 by 3 centimeters. Why 2 by 3? Because we know x is equal to 2 by 3 from here, right? And then what is going to be the area of this triangle, and then 6 times the area is going to be the answer. So let's look at it. Let's draw it a little bigger. This is an equilateral triangle. Let's say I drop this line which which basically meets the base in this point. Actually this will be the midpoint because it's an equilateral triangle. So this is going to be 60 degrees, this is going to be 30 degrees, this is going to be 30 degrees, this is going to be 60 degrees, right? And this is going to bisect this line. So this is going to be 2 by 3 divided by 2, this is going to be 1 by 3, and this is going to be 1 by 3, right? So this is 1 by 3, this is 1 by 3, this side again is 2 by 3, and let's say this side is h, right? So now we have a 30, 60, 90 triangle. We can easily find out, or even using Pythagoras theorem, what do we get? We get h square is equal to 2 by 3 square minus 1 by 3 square, correct? So what do you get? 4 by 9 minus 1 by 9. So what we get is 3 by 9. So h becomes, h is equal to root 3 by 3, which is going to be 1 by root 3. So if h is equal to 1 by root 3, the area of triangle is going to be half of h, which is 1 by root 3, into the base. The base is going to be 2 by 3, correct? So this half and 2 get cancelled. So what we get is 1 by 3 root 3 as the area of triangle. So area of hexagon is going to be 6 times the area of triangle, which is 6 into 1 by 3 root 3. So this 6 and the 6, 3 get cancelled, we get 2. So we answer is 2 by root 3. So let's look at this problem now. You can pause the video and see if you can solve this. A magic wand can increase size of any object. If Rose used the magic wand to increase the size of her solid cube such that every side increased by 10%, what was the percentage increase in the surface area? Okay, so let's see the old numbers and the new numbers, right? So what is going to be, let's say the side of old cube was 10x. What would be the base area then? Base area is going to be, it's a cube, so base area is going to be side square, so it's going to be 100x square. And what is going to be the surface area? Surface is going to, area is going to be 6 times the base area. So what is going to be the new dimension? New side is going to be, the side has been increased by 10%. Now that means 10% gets added to it, to the size. The 10% of 10x is x, so x gets added, so now it becomes 11x, right? What is the base area of the new cube? So it's going to be 121x square, right? Square of 11x, and surface area is going to be 6 times 121 of x square, right? So what the question is, what was the percentage increase in the surface area? So the percentage increase, let's find out. New quantity by old quantity. So new quantity is 6 into 121 by x square divided by old quantity is 6 into 100 by x square. X square get cancelled, 6 get cancelled. So new quantity is 1.21 times the old quantity. That means there is an increase of 21%. So there is a 21% increase in the surface area. Let's look at this problem. You can give it a try. Diagonal of a rectangle is 10 centimeter while its area is 22 centimeters square. Okay, so let's say this is the diagonal of a rectangle, 10 centimeters square, and the area is 22 centimeters square. Okay, what is the perimeter of the rectangle? Okay, let's say the lengths are A and B. So what do we know? Diagonal is 10 centimeters square. That means A square plus B square is equal to 10 square, which is 100. So that is one equation we know. The area is 22 centimeters square. So A into B is 22. That much also we know. What is the perimeter of the circle? So what do we have to find out? perimeter of the circle. That means 2 times a plus b. Now look at it, look at all these quantities. A square plus b square is known, ab is known, and we are supposed to solve a plus b, right? So we'll use this special product. A plus b square is equal to a square plus b square plus 2ab, right? So what is a square plus b square here? We get 100. What is 2ab? 2ab, okay, 2 into 22, so the whole thing becomes 144. So a plus b square is equal to 144. So what is a plus b? So a plus b becomes 12. And what would be 2a plus b? The perimeter 2a plus b is going to be 24. So the answer is perimeter is 24 centimeters. So thanks for watching. I hope you enjoyed this session, and I look forward to seeing you in the next session. Thank you.